Emily cycles along a path for 2 minutes. She starts from rest and accelerates at a constant rate until she reaches a speed of 5 meters per second after 40 seconds. She continues cycling at 5 meters per second for 60 seconds and then decelerate at a constant rate until she stops after a further 20 seconds. On the grid, draw a speed time graph to show Emily's journey. This is speed in minute per second and the time is in second. The total journey is of 120 seconds. That is 2 minutes journey. And she starts from rest and accelerate at a constant rate. So speed is increasing with constant rate means that it is a straight line. In 40 seconds it reaches to 5 meter per second. So I have drawn from 0 to 40 for 40 minutes. The speed is 5 meter per second. Because acceleration is constant, so it is a straight line. And she continues cycling 5 meter per second for 60 seconds. For the next 60 seconds, the speed remains constant, 5 meter per second. And from 40 to 60, it will be a 100-second journey. Therefore, from 40 plus 60, it is 100. So for the next, it remains constant. And then she decelerates at a constant rate. So the speed is decreasing at a constant rate. Then it is again a straight line, and she stops after further 20 seconds. So 100 plus 20 is 120. So this is her graph of the whole journey. Now we have to calculate the acceleration of Emily. And the speed is increasing in this part of the journey. So speed is increasing, it is acceleration. Acceleration is over here. And in speed time graph, acceleration is the gradient of the straight line. And gradient is rise over run. This is rise and this much is run. Rise is 5 and run is 40. It is 5 over 40 and simplification will give us 1 over 8. Therefore the acceleration is 1 over 8 meter per second square. Calculate Emily's average speed for the journey. The average speed of the whole journey is total distance over total time. In speed time graph, the distance is basically the area under the graph. We have to calculate what is the area of this trapezium. It is half into height. Height is basically the gap between two parallel lines. The gap between two parallel lines is 5. The height is 5. And then sum of the parallel sides. One parallel side has length 120 and second parallel line has length that is 60. And the total time is 120. And after simplification, it is 3.75 meter per second. Ali leaves home at 10 to cycle to his grandmother's house. He arrives at 13. The distance time graph represents his journey. So the distance is in kilometer and the time is given on the x-axis. Calculate Ali's speed between 10 and 11:30. And 11:30 is here between 11 and 12. Now we have to find the speed because it is distance time graph. Speed is the gradient of the line, the gradient of distance time graph. The rise is from here to here and it is this point. Look here, from 10 to 20 it is a gap of 10 kilometers and it is divided by 10 small boxes. 1, 2, 3, 4, 5, 6, 7 like that. So it means that one small box is about 1 kilometer. So it is 12 kilometer. So the rise is 12 kilometer and then run is 1 hour 30 minutes and it is 1.5 hour. Therefore that speed which is rise over run here, it is 8 km per hour. Show that Ali's average speed for the whole journey to his grandmother's house is 12 km per hour. The average speed of the whole journey is total distance over total time. and the total distance covered is from here, and we put mark on this point, and this is 31, 32, 33, 34, 35, 36. It's 36 kilometer. The distance covered is 36 kilometer, and the time taken is like 1 hour, 2 hour, 3 hours. Therefore, the average speed of the whole journey is 36 over 3, that is 12 meter per second. Sorry, it is 12 kilometer per hour. Change 12 kilometer per hour into meter per second. 12 kilometer per hour means 12 kilometer per 1 hour. Per mean 1. To convert kilometer into meter, we have to multiply by 1000, and to convert hour into minutes, we have to multiply by 60. Therefore, it is 200 meter per minute. Ali stays for 45 minutes at his grandmother's house and then returns home. He arrives home at 1642. So we have to see how to represent this 45 minutes on the graph. Ali stays 45 minutes at her grandma's home, and you can see from 13 to 14 it is 1 hour. This 1 hour means it is 60 seconds. This gap is 60 seconds, and there are 10 boxes between them. So we have to see how many boxes will represent 45 minutes. 60 minutes represent 10 small boxes, and 45 minutes will represent how many small boxes? Now by cross multiplication, 45 minutes represent 7.5 boxes. So from this point to 7.5 boxes, so this is 7.5 boxes. It is 1345. So Ali will stay. So this is the graph of his stay at grandma's home. As the distance is not increasing, so this graph shows that the rest position of the Ali at grandma's home. After that, he comes back he reaches home at 1642. Again, 60 minutes represent 10 boxes, and how many small boxes will represent 42 minutes? So there are 7 small boxes will represent 42 minutes. From here, 1, 2, 3, 4, 5, 6, 7. So when he will come back, this will be the time. So we will draw a graph from this position. So this is his graph towards his home back. In distance time graph, this whole x-axis represent the starting position. Right now it is the home line, and this top position is the grandma's house. This whole horizontal line, which is 36 kilometer line, this whole line represents the grandma house, and the x-axis represent the Ali's home. Now we have completed the distance time graph. The diagram shows speed time graph for a car traveling along a road for t seconds. This time is t, and it is not given here. To begin with, the car accelerate at 0.75 meter per second square for 20 seconds to reach the speed of v meter per second. And this is the highest speed, which is also not given. To find these two unknown values, we must be given two information in the question. So read the statement very carefully. The first information is over here, that is car acceleration is 0.75 meter per second square for 20 seconds. So here acceleration in speed time graph, acceleration is the gradient of the line. So the gradient of this line is 0.75. Therefore acceleration is rise over run. Just plug in the values. Acceleration is 0.75 and rise is v meter per second and run is 20 seconds. Now just by multiply we will get value of v. V is 15 meter per second. This is 15 meter per second. So we have one unknown. To find this unknown, the t, we have one another information must be given in the question. Here in the part 2, the total distance traveled is 1.8 kilometer. Calculate the total time t of the journey. The distance is basically in speed time graph, the distance is area under the graph. Now we have to calculate what is the area of this. The speed is in meter, the unit is meter here, but the distance is in kilometer. This is 1.8 kilometers. So we will convert this into meter so that we have the same units. It will be just multiplying it by 1000. It is 1800 meter. Now the area of the trapezium is half into height, that is 15, and the sum of the parallel sides. The height is this much, 15, and the one parallel side is which is equal to t length. The total length of this side is t, and the total length of this is 110 minus 20, that is 90. So sum of the parallel sides are t plus 90, and the height is 50. So we just put the value here, half height into sum of the parallel side, t plus 90. And this is this area, and we know that area under the graph is basically distance. So this is the total area of the graph, and the total area of the graph represents the total distance covered, and that is 1800 meter. Now just by simplification, we have brought this to, it is dividing over here, it will be multiplying, and it is multiplying, it will be in, it is in the denominator right now. And just simplification, it is 240, so t plus 90 is equal to 240, and solving this equation, 90 will come over here, 240 minus 90, therefore t is 150 seconds. The total journey time is 150 seconds. This question is not the part of this topic, it is separate topic, so we will leave this. Next question is also about distance time graph, and distance in kilometer, and the time is given on the x-axis. The distance time graph shows the journey of a train. Find the speed of the train between 7 and 7:30. This is the part of the journey between 7 and 7:30. It is a straight line, and in distance time graph, the speed is basically the gradient of the line. So we have to find the gradient of this line, which is rise over run. Here rise is this one, that is 50, and run is half an hour, 0.5 hour. So rise is 50 and the run is 0.5 hours. So after simplification, it is 100 km per hour. Speed is 100 km per hour for the first half an hour journey. Find the average speed for the whole journey, and it is total distance over total time. Total distance over total time. The total distance covered is 200 km, and the total time is 2 hours 10. The total time is 2 hours 10 minutes. So 2 or 10 minutes. So we have to convert this 10 minutes into hours as well. So to convert this 10 minutes into hours, I have to divide this 10 by 60. So it is 1 over 6. So now 2 hours, 1 over 6. So I will add both of them. It is 2 into 1 over 6 hours. Now I will use this one time here. So 200 km total distance covered over 2 into 1 over 2 into 1 over 6 hours. And now after doing simplification, 200 divided by shift this one, and it will be 2 1 over 6. Okay, and just plus this equal, it is It's 90.3, 92.3, 92.3 kilometer per hour, the average speed of the whole journey. The speed time graph shows the first 30 minutes of another train journey. The distance traveled is 100 km and the maximum speed of the train is v km per hour. Find the value of v. There is one unknown in this graph, so we must be given one information, and that information is the distance traveled is 100 km. And in speed time graph, the distance is basically the area under the graph. So the total area is equal to 100. The area of the trapezium is half into height. The height is this much, which is equal to V, and the sum of the parallel sides. One parallel side is length has 30 minutes and the second one has the length 25 minus 5, 20 seconds. 30 and 20. Half into height, height was V, and the sum of parallel sides were 30 plus 20. As units are used kilometer and hour, and on the x-axis it is just minutes, so we will convert these minutes into hours. And look here, these parallel sides are representing the x-axis, which are the time in minutes. So this 30 and 20 are minutes basically. So to convert them into hours, I will divide here by 60, like this. And this is the area of the trapezium, which is equal to the distance, total distance covered. And the total distance covered is given in the question, which is 100 km. Therefore, it will be equal to 100. Now, after simplification, we will get this one, and using the cross multiplication, the V is 240 km per hour. In the next part, find the acceleration of the train during the first 5 minutes and give your answer in meter per second square. This is the time for 5 minutes, and the acceleration in speed time graph is basically the gradient of the graph. So we have to find the gradient of this graph, which is rise over run. Rise is this V, which is 240, and run is 5 minutes. We just plug in the value here, as we have to give answer in meter per second square. So first of all, we will have to convert this into meter per second. So this is 240 kilometer. We have to multiply by 1000 to convert this kilometer into meter, and then we have to divide in the denominator by 6. First 60 mean this hour will be converted into minutes, then we multiply again by 60 to convert those minutes into seconds. And then after doing simplification, it is 66.67 meter per second. And in the denominator, it is 5 minutes. So we have also convert this into second. So just multiply by 60 here. And after doing simplification, the final answer is 2/9 meter per second square.